Uh, in this video, I'm going to talk about second derivatives. So, because since we know that the gradient and the divergence and the curl are only the first derivatives, because we have the first order differential equations for the gradient and the divergence and the curls. So now we can construct 5 second derivatives. So I'm going to write the first one. So this is called as the divergence of gradient. So divergence of a gradient. So this is defined as del dot, because when we have divergence we have to have a dot product. So now divergence of gradient. So let's say we are considering the scale of t, so we have del t. So grad, that means the divergence of a gradient t. So I'm going to write the second one, that is curl of a gradient. So actually curl of a gradient means that we have to deal with the cross product. So that means this is the del, so del operator, so del operator cross product with grad t. So now the third one is going to be gradient of a divergence. That means we have del operator here, and we have grad, sorry, del, we have the divergence of vector field v. So t is a scalar, so v is a vector field. So now the fourth one is going to be divergence of a curl. Divergence of a curl. So that means we have a dot product. So we have del cross v, because when we have curl, so we have to have a vector field. And the final second derivative is going to be curl of a curl. So this is the fifth and the last second derivative that I'm going to talk about. So that means curl of a curl means that del operator cross product with the del cross v. Okay, now these are second derivatives actually, because when we have del operator dot product with the del operator, so you know that this is going to be daba x, daba over daba x, and this have daba over daba x. So we have x hat here, and we have a second order differential equation. So right now I'm going to show you how these things works. So I'm going to take the first one, that is the divergence of a gradient. So divergence of a gradient. So now I know that this del operator can be written as dab over dab x, x hat, plus dab over dab y, y hat, dab over dab c, c hat. So the product with dab over dab x, t, dab t over dab x, x hat, dab t over dab y, y hat, dab t over dab c, c hat. So now I'm going to take the dot product. So you know that x hat dot x hat is equals 1 and x hat dot y hat is equals 0. Likewise, these are basic things. Now I don't need to go through with these steps. So you know that when we have daba over daba x twice, because it is going to be squared, because daba over daba x here, daba over daba x here, this is just like common term, so you have a squared here, so that means daba squared daba x squared, because this is a this is not just like a number, because this is a differentiation. So this when this is going to be squared, so you have to write in this way. So now you know that there is a scalar, so you have to use that scalar as well. So now you have daba squared over daba squared t over daba x squared. So now you have daba squared daba squared t over daba y squared, because you know that y hat dot y hat is equals 1. So you know you will have daba squared t over daba c squared. So this is going to be my divergence of gradient t. Okay, this can be written as del squared t. This is just like that, because now if you say that you can write in this way as well. So divergence of gradient t is going to be equals, so you can put the parentheses in between these del operators. So you have this, so you know that if we calculate the dot product of del operator and del operator, it is going to be del squared t, because the magnitude of del operator is going to be del, and the magnitude of the del operator will be del, so it's going to be del squared t. Sometimes because we know that from the physics, this term is considered as the Laplacian of scalar, Laplacian of scalar t. Okay, now I'm going to take the second second one, actually the curl of grad t. Curl of grad t. So this can be so you know that this gives you a vector. Actually the final outcome will be a vector, so you have to have that matrix format. So this is x hat, y hat, and c hat. So you know that from we have this del operator here and del grad t here. So you know that you have to use this as the first vector, you have to this as the second vector. So you have daba over daba x here, daba over daba y here, daba over daba c here, because these are the vector components of the del operator, and the vector components of the grad t is going to be daba t over daba x, and daba t over daba y, and daba t over daba z. So okay, I'm not going to do this for you because this is going to be an exercise for you. So when you simplify this determinant, it is going to be 0 vector. You can say this as null vector, because since this vector gives you, since this cross product gives you a vector, so you cannot say that is equals 0, because this is always going to be a vector. So this is considered as the null vector. So I'm not going to do the calculation for you, because you have to do this calculation as an exercise. So when you are going to find this x hat, y hat, and c hat, it's going to be the coefficient is going to be 0. That is why we have a null vector here. So try to do this, and you will get the result as null vector. Okay, this means that the curl of a gradient is always going to be 0. So that means there is an important theory behind this. So that means we have a del operator here and the grad t. So you can say that this vector as b. So you know that this is equals to null vector. So if cross product of del operator with a is going to be null vector, this means that there should be a scalar field T such that B is equals grad T. So there is always going to be a scalar field in such a way like this. If the curl of grad T is going to be 0. So I hope you understand this section. So I'm going to go to the next second derivative, that is going to be my gradient of a divergence. So I'm not going to write this again and again. So this is going to be gradient of a divergence. That means we have gradient of a divergence. That means we have to use a vector field. So this is the gradient of divergence. So it's going to be a little bit of complex simplification. So I'm going to do this for you because it's going to be a little bit harder, but this is seldom used in physics, so we are not going to go deeper into it. So we have w vx over w x and w vy over w y and plus w vc over w c. So now you have w squared over w squared vx over w x squared x hat plus w squared vy over y squared y hat w squared vz over wz squared z hat. So this is going to be a vector, and now you have other terms as well. W squared vy over w x w y x hat w squared over w squared vy over w squared w squared vx over w x w y hat. Likewise, you can write these terms. Actually, you will have to expand this simplification. So when you expand, you will have x hat terms and y hat terms and z hat terms. What I'm trying to say is that you will get a vector here. So when you are going to find the gradient of a divergence, you will always get a vector. So this is seldomly used in this is actually very rarely used in physics. So I'm not going to teach you deep into this gradient of divergence. So I'm going to the next second derivative. So this is going to be a little bit important. I think it's really important actually when it comes to this. So that means we have to use the divergence of curl. So divergence of curl is written in this way. So we have a vector field v. Okay, this is going to be a 0. This is not going to be a null vector because this is going to be 0 because this is just like a scalar triple product. So a scalar triple product means we have we are going to get a scalar as the final outcome of this term. So now this is an exercise for you to prove this one. So I think you can do this. So you have to prove this one. So I'm not going to do this for you. If you are struggling to do this, comment it. I will post a video on this. So what you have to do is that you have to put this into this is a curl. This is actually the cross product of del operator and the v vector field. So what you have to do is that you have to put this into the matrix format, and you have to calculate the determinant of that matrix, and then there is a del operator again here. So when you are finding the cross product between del operator and del operator and v vector, you will get another vector called, let's say, d vector. So you will have a scalar product between del operator and the d vector. So that means you will get a scalar. So this scalar value is going to be 0. So what you have to prove that. So if this thing's going to be 0, so there is vector field such that actually this divergence of a curl is going to be 0. That implies there should be a vector field v such that d is equals to del cross v. Okay, in this video I'm not going to talk about the fifth and the last second derivative, because it gives you it's not give you anything new about the result. So when we compare the result of this curl of a curl, it's not going to be anything new. So I'm not going to talk about that second derivative, the fifth second derivative. So this is all for my differential vector calculus videos. So I'm going to next talk about I'm going to talk about integral vector calculus. So I hope you understand this differential vector calculus. Now we were talking about the second derivatives actually. So I hope you all understand this clearly. So I hope to meet you in the next videos. So thank you.